everybody. I have some notes today on Cranmer's rule and determinants. Give this a shot. So first thing we need to talk about is that not all matrices have inverses, okay? And your determinant is going to help you determine if it does. So the determinant determines if you indeed have an inverse. You don't want to go through all that work and then have it not come out for you at all right? So we're going to take our matrix. This is a 2 by 2 matrix. And again, we have to be working with square matrices in order for it to work. Our determinant, what we're going to do is we're going to cross multiply A times D minus C times B. So if the determinant is equal to zero, then we have no inverse, all right? There's absolutely no inverse. Nothing you can do there, all right? If the determinant is not equal to zero, then it's invertible. It has an inverse, okay? So we're thrilled for that. So what we're going to do is we're going to take a look at these example problems, and we're going to find the determinant and then determine if it does have an inverse. So what I'm going to do is I'm going to cross multiply. So first thing I'm going to do, determinant is equal to 4 times 5 minus, and then go the other direction, 3 times negative 2. All right, so that's going to be 20 minus negative 6, which is plus 6. So my determinant is equal to 26. So do I have an oh gosh, you can't even see that on the paper. There you go. So do I have an inverse? Yes, yes we do. Yes, has an inverse. Okay, let's try the next one. So we'll cross multiply. Determinant is equal to 6 minus 6. Uh-oh, my determinant is equal to 0. So just like I said above, no inverse. Okay, no inverse. How about the third one? Cross multiply, so D is equal to, see 1 times 0 is 0, minus, cross multiply here, negative 1 times negative 1 is 1. So my determinant is equal to negative 1, so yes, there's an inverse. Okay. So that's how I find a 2 by 2. Now, what's going to be a little bit different is we're going to work now with a 3 by 3. So let me move this up a little bit for a 3 by 3. So to find the determinant of a 3 by 3, I'm going to do something called basket weaving. And what I need to do here is take my matrix and I'm going to recopy it. 1, 2, 1, negative 2, 1, 0, 3, negative 1, 4. Now here's the problem. If I go ahead and I weave and I cross multiply, I'm going to leave a lot of numbers out, and that's a problem. So here's a little trick. We're going to take these first 2 rows and we're going to recopy them exactly as is. So 1, 2, 1 becomes 1, 2, 1 over here. And negative 2, 1, 0 is going to just pop in right here, okay? Now, this is where if you're messy like me, you have to be really careful. What we're going to do is we're going to multiply as we go down. So our determinant is equal to, I'm going to set this up so I'm ready to go. 4 times 1, which is going to give me 4. And then I'm going to multiply 2 times negative 2 times negative 1 times 1, which is going to give me positive 2. And then 3 times 2 times 0, which is 6. Oh gosh, no. 3 times 2 times 0 is 0. Okay. Now I'm going to go the opposite direction. I'm going to write with pencil this time. I'm going to go this direction and I'm going to multiply these 3 together. Now you can see with this beautiful basket, I left out a 2, but I got the 2 over here. And here it looks like I left out a 1, but I've got the 1 over there. So I'm going ahead and multiply 1 times 3 is 3. 0 times negative 1 times 1 is 0. Oh, I love those zeros, don't you? Plus 4 times 2 times negative 2 is 4 times negative 16. Okay, so let's see, I have, back to my pen, I have 4 plus 2, which is 6, and then I have 3 plus negative 16 is, negative 13, and then the opposite, so it's going to become negative 13, which then gives me a positive 19. So does this matrix have an inverse? Yes, yes, it has an inverse. Now that's going to save us so much time given that a shot before I go ahead and take the time to put all that into our calculator. I know it felt like it took a long time to do that one, but really, really not that bad. Not that bad at all. Okay. So that is determinants and determinants. No, just determinants.